everybody. Good morning, good afternoon, or good night to wherever you're tuning in from. Thanks for joining both me and Brian Sumner today to discuss really how the VUX-120 is being used to impact the mining industry and how it can be used in a variety of these applications. To really start out, to kind of get a judge of where everybody's at with a lot of this stuff, do you currently use UAV LiDAR? Get everybody up in the morning to see where everybody's at. And then if you do currently use UAV LiDAR, are you using it for the mining industry at all? Yeah, sorry to surprise everybody with a pop quiz in the morning, but it always woke me up in high school. Again, thank you everybody for attending. To start out, we'll discuss VUX-120's capabilities. Start out, the VUX-120-23 is our one of our highest end UAV LiDAR scanners, providing highly accurate and highly dense data for any of your surveying needs. I'm Tyler Shriver, the ULS sales engineer here at RIEGL USA. I work with anything drone related here, from integrations all the way to testing these systems and selling them as well. To start out, the VUX-120, not only are you getting quantity of data, you're getting the quality of data as well. With a field of view of 100 degrees, you're able to collect large swaths of data, especially with its nadir forward backwards scanning pattern. This is a unique scanning pattern that allows you to collect not only the nadir view, but also vertical facades as well, with a measurement rate up to 2.4 megahertz and up to 400 lines per second. Lack of data is not an issue here with the scanner. You almost have to be careful with over collecting, as well as the scanner collects up to 32 targets per pulse. So any sort of vegetation penetration you need to get any sort of undergrowth or ground modeling is easily collected, as with up to 2 million points being shot per second, up to 32 targets per pulse. At that point, you are almost painting the ground underneath. With this, the scanner does have a 5mm precision at 150 meters, meaning you're not only getting very dense data, you're getting very precise, which typically leads to more accurate data as well. With this, what is nadir forward backward scanning? Nadir, as most of us know, is scanning straight down, which is great, but with a forward view, you're able to get the front side of buildings, vertical facades, power poles, trees, as well as the back side, allowing you to get 3 different look angles for different vegetation, for different vertical facades, walls of buildings, walls of open pit mines, sides of power poles, anything that you might need to originally fly off the side of to collect, you're now able to fly almost directly over to collect these data. With the VUX-120, we're not only a sensor manufacturer, they are fully integrated systems with an IMU options of an APX20 or an AP plus 50 with a RISYS CU for any of your higher altitude projects like manned aircraft. For UAV operations, we typically see the IMU APX20 IMU 90 as it is lighter weight than the IMU 82 with a lower cost, allowing you to fly longer in the air with any drone that you might be using. With this, we do have several camera options. Up to 3 cameras can be integrated, with options at nadir and oblique, with RGB options such as the Sony a6100, the Sony a7R4, and the new industrial Sony ILX LR1, coming in around a third of the weight of the a7R4, with it being a 61 megapixel camera. You're getting longer flight time with the quality as well. With this, we have the option to integrate with a 21, 35, or even up to 50mm lenses, depending on your photogrammetric needs. For our cameras, we do offer multispectral based off of our Sony a6100 or a7R4, as well as thermal options with the FLIR Tau 2. With this, you're able to collect almost all the data you need off of one platform, as it does trigger off of the internal computer with the RIEGL VUX-120. In terms of collecting, we To plan out, we use something called rack parameter to really show you what swath width, what density you're getting with the scanner. If we were to program the scanner at 2400 kilohertz at the max pulse rate and fly at 8 meters a second at 400 feet per second, on average, we're looking a 953 foot swath width with a lateral line separation of 700 feet, as well as an average point density of nearly 900 points per square meter in a single pass. This is accounting for one grid rather than a double gridded system. With this, we're also looking at nearly a little over 6 square kilometers per hour of collect. So if you are using something as a gas hybrid drone, you're able to collect large amounts of data very quickly. With this, we do work with several UAV manufacturers here in the US at RIEGL USA, such as Skyfront, Inspired Flight, Free Fly Systems, and today with Clymer Farner Barley, we'll be looking mainly at the Harris Aerial hybrid drone. For this, these aren't specific integrations to us. We can integrate with several other drones as well. As long as the payload capacity is to where it needs to be, we can fly it on almost anything. For this, in terms of data processing, we use a software called RIEGL, which is our own software. Software itself is based on your computer. It's not cloud-based, meaning your data processes out as fast as your computer is. Within this RIEGL, we can georeference all our point clouds via RIEGL, any sort of conditions you're in, as well as tightly calibrate and align these point clouds as well via RIEGL Precision to then bring down all of your control as well as reference everything. And finally, what are some of our use cases in mining? You know, the collection of vertical facades and objects is large with the VUX-120, as well as the monitoring of mines. The detection over time due to safety, any sort of collapse you might have. With the 5mm precision that you're getting, you're easily able to detect these changes, as well as utilizing these reflectances to detect different materials. A lot of times when you're digging, you need to find your specific type of rock or mineral you're looking for. Due to the high reflectance values that we calibrate these scanners with, we're able to easily detect these in the point clouds. Scanning areas under vegetation, such as sites that may not have been active in a while that need monitoring, is easily done with the 32 points per square meter, as well as volumetric analysis with these scanners. As well as some other use cases for these scanners are forestry, construction, so your pre-site surveys where it might be forested, all of your grading. Due to the high precision of these scanners, we can pull down great accuracies. All construction phases during monitoring, as well as your quality control afterwards for any as-builts that you might be doing. Utility mapping, due to the nadir forward-backwards scan pattern, we're able to pick up the size of poles as well as the lines itself very easily. DOT collection, any sort of right-of-way, large land surveying, archaeology, and really any use for LiDAR that you might be using. With this, I will pass it on to my colleague Brian Sumner at Clymer Farner Barley to discuss the applications of what he got with the VUX-120 on his mine site. Thank you for your attention. I will now pass it on to Brian.
Thank you, Tyler. Good morning, everybody. As Tyler mentioned, my name is Brian Sumner. I serve as the Geospatial Division Manager here at Clymer Farner Barley Surveying. About 2.5 years ago, Clymer Farner Barley established this new division, which now integrates both UAV, LiDAR, and static scanning into our workflow. So hopefully we will be venturing into mobile LiDAR in the near future. Just a little bit about our company. CFB is a surveying and civil engineering firm based out of Central Florida. We operate out of 3 offices, headquartered in Wildwood, and branch offices are in Ocala and Clearwater. We handle a wide variety of projects, mostly around land development, route surveying, and construction staking, but kind of a little bit of everything. Today we will be looking at a project involving a lime rock mine located in North Marion County. The entire project was about 900 acres in total, made up of 5 pits, including 3 active mines. There was a wide variety of environments on this property, such as you would expect on a mine, significant elevation changes. Some of the walls of the mine were over 100 feet tall, very dense vegetation, wetlands, roads, buildings, improvements, all that kind of stuff. So there's quite a bit out there, as you would expect on 900 acres. The data collected from this project will be utilized for environmental resource permitting through the Florida Department of Environmental Protection. For this project, we employed the RIEGL VUX-120, which we've been using for about 8 months now. We have it mounted on a Harris 6A hybrid UAV, which captures data at an exceptionally high resolution. As Tyler went over previously, the VUX-120 utilizes 3 separate lasers for data collection, as well as extremely high capture rates. For this project, we knowingly went a lot bit excessive actually. With our capture settings, we had a pulse repetition rate of 2.4 megahertz, which is the highest setting, and 400 scan lines per second. And we flew about 13 miles an hour and had an overlap of about 50%. So we had a ton of data to work with. The settings used resulted in a point density of about 2,200 points per square meter, which is way more than you would actually need. With these settings being intentionally excessive, our objective was to explore the capabilities of such high resolution in this project type, as well as used for marketing and geospatial promotion, all that kind of stuff. As you would expect with such a high point density on a 900-acre site, the raw scan data turned out to be pretty substantial. Our raw data prior to processing was over 600 gigabytes. The specific mine within this project that we will be looking at closer has an estimated volume of 4.5 million cubic yards. Our geospatial team collaborated with multiple field crews whose primary task was to locate most of the improvements using the same control as our aerial targets to keep everything unified. Given the 100+ foot elevation drops, intense heavy equipment traffic within the active mines, and the extensive area to be recorded, we opted for a combination of UAV, LiDAR, and conventional field crew efforts. This approach proved optimal for efficiency, cost effectiveness, and of course safety. To have a field crew walking around the edges of the cliffs and heavy equipment running around, it gets a little hairy sometimes. So the integration of the conventional field data with our LiDAR data actually proved to be worked out really well. For data extraction, we experimented with various methods to achieve the best results while maintaining manageable file sizes. Ultimately, we adopted a variable grid size approach for the ground shots, ranging from 3 feet in areas with significant elevation changes to 50 feet in more level regions. Despite this, it was necessary to divide the surface into multiple files, 5, if I remember correctly, 5 different drawings, and reference each of those drawings into an overall surface to produce a usable product for the engineers. Initially, working within a single drawing was just a nightmare. It was just way too dense. As you can see from the scans, the density of the points that we got, it essentially looks very similar to a mesh. I mean, this is one of the stockpiles on the site, and with the point density that we got intentionally, the result that you get out of it is mind-blowing. It's incredible. Here's a little bit of the surface that we got. One portion of it that we had referenced in, there's obviously, you can see quite a bit of elevation change around the edges of the mine, stockpiles in the middle. Throughout our diverse range of products. Utilizing the VUX-120, the scanner has consistently delivered exceptional performance. We love it. We use it any chance we get. We're still trying to find different avenues that we can use it on. It's because it's so versatile. The high accuracy and adjustable performance capabilities of the scanner are invaluable and allow us to maximize our process. It gives us highly accurate data at whatever point density suits the job. Vacant land and stuff like that, you obviously don't need nearly the point density as if you're flying a commercial project site. So the ability to tailor the scanner to fit the various job types is pretty essential to our workflow. So we use it every chance we get and have had no problems with it. It's a workhorse for us. So with that, I will turn it back over to Tyler, and appreciate you guys tuning in.
Thank you, Brian, for the presentation. I'll now open the floor up. If anybody has any questions for either me or Brian, love to answer them. Anything that you have questions on may not have been covered, feel free to ask. Brian, one of the questions we got is, what's your average flight time for the Harris and the VUX-120?
For this particular setup, it's actually pretty handy. So per flight, we end up flying about an hour and 15 to hour and 20 minutes. The good thing about this drone, for one, it's certainly capable of handling the payload with the VUX-120, and we have the Sony A7R4 mounted onto it. But bring it back, refuel, and send it right back up without having too much downtime. So it actually works out very well. It does have a battery switchover if you want to take off the gas-powered generator. For the most part, we leave the gas-powered one on there just because the flight time is so much more. So yeah, about an hour and 15 to hour and 20 minutes.
Next one I got was for integration. What's the average weight of the VUX-120? Believe your system, Brian, with the A7R4, the APX20 IMU 90, you are looking closer to 4.25 kilograms. So for one of the questions you have is, after RIEGL process, what software are you using for any sort of ground classification?
So after we get the point cloud out of RIEGL process, most of the stuff that we work with from this drone is brought into TopoDot. Even if it's not necessarily the ideal case for TopoDot, it can certainly handle it, and it's plenty powerful, it's efficient. From time to time, we will use Trimble Business Center. It really just depends on the project, but I would probably say 80–85% of what we do comes out of RIEGL process and goes into TopoDot.
Perfect. Absolutely. Thank you. So from Nathan, how easy or difficult is it to colorize the point cloud within the RIEGL software? From my experience, Nathan, it is actually a two-step through a camera data wizard and a color scan wizard, where you actually import all of your camera data into the RIEGL software. It will then use the EIFs to line up with the trajectory and your point cloud to then colorize all of your pictures. From here, we can actually then export the pictures through and tag them to the trajectory and or EIF. So then you actually do have geotagged images if you do need to use for them for orthomosaics. And then with the 3 different look angles, can you actually view the separate channels? Yes, you can view the separate channels. If you are just looking for the vertical, when you do process it out, it does separate them to 3 different channels. So you're able to actually look at them separately. From there, it looks like we did answer most of the questions. If we didn't answer your questions, we'll send a follow-up email just to talk with you a little more. And then finally, I do have a question for the audience. After this webinar, what would you like to see a webinar next? Utility mapping, leveraging multiple scanner types for data fusion, or introducing a new RIEGL RIEGL, the collection and processing updates. Well, thank you everybody for attending today's webinar. Thank you, Brian, for explaining how you're using the VUX-120 for some of these mining operations. And if you have any questions, please feel free to reach out to me, or I can even, if you're looking for services, Clymer Farner Barley is a great resource to go to. Thank you, everybody. Have a good evening or good afternoon, depending on where you're at. And thank you very much.
Thanks, everybody.